So this is exercise 8B question 3, which is requested by Callan, particularly to get an understanding of R0, R and RS. So let's address that to start with. So R0 is the opening position. So here is the opening position of the ball. The opening position was at 0.25. Now we're told that the closing position is Q along the corridor and then 10 up the stairs at point B. So R is your final position, R0 is your initial position, so S is the displacement, that's the actual journey you've done to get from R0 to R. So in normal circumstances you take R0, you'd add on S to get R. But with the information we've been given here, we're going backwards. We're taking R, subtracting R0 from this to give us S. So answering the question more specifically, part A is just the assumptions at the top. Now with part B, what do we know about the ball? We know it kicks off with initial speed 3pi plus pj, so that's 3pp. We know that the acceleration is gravity, so that's going down obviously towards the centre of the earth, so 0 minus 9.8, and the time taken is 2 seconds. So using v equals u plus at, we can see that v is 3p, p minus 19.6. So we're just going to park that for now. So that's what v is in terms of p. Now if we just move over now to looking at the displacement, so this was the bit I was talking about beforehand. The displacement is r minus r0. Where we finished, take away where we started, is the actual displacement, the actual journey we've taken. So that is q minus 15. So now using s equals ut plus half at squared, well, we know the displacement travelled is q minus 15, just work that out. We know t is 2 and u is 3p over p, and that we know the time is 2 seconds, and we know the gravity. This allows us to, well, this is what we get. Now, if we just focus on the j component, our only unknown is p. So we can solve for p and to work out that p is 2.3. We then substitute that back in to our v equation up here, and that allows us to work out what v is, now that we know what p is. So v is 6.9 minus 17.3. Now for part C, we're going to focus on when the ball hits the sea. So what do we know about the ball? We know its initial speed was 3pp, and because we now know that p is 2.3, we know that the initial speed of the ball was 6.9, 2.3. And we know it's fighting against gravity. So using s equals ut plus half at squared, we can get a vector for the displacement. Now, when does it hit the sea? It hits the sea when it's gone x along the corridor and minus 25 from where we started down the stairs. So it hits the sea at x minus 25, so that's the final displacement. So this is an equation for displacement in terms of t, and this is the displacement in terms of where we end up. So we could either equate the I or the j components. Obviously at the moment both x and t are unknowns, so we're going to equate the j components to making this equal this, giving us a quadratic, and that tells us the time before the ball hits the sea. Now substituting that back into the I components, we can therefore see that the x component of the displacement, the amount along the corridor, is 17.289 meters. Now, turning our attention to the boat, which is just busily minding its own business going along the x-axis from naught to c, we know the ball hits the boat. So what do we know about the boat? We know the distance it has travelled by the time it gets hit is 17.289. We know the time taken for it to get there is 2.5056 seconds, and we know the boat's initial speed was 0. So substituting that into s equals ut plus half at squared, we can work out that its acceleration was 5.5 meters per second squared.